Hi, and welcome. This is Mr. Bell's flipped classroom video on literal equations for Mr. Bell's physics class. Okay, so let's get started. By the end of this video, you should be able to know what a literal equation is and how to solve for one. So first of all, a literal equation is just an equation that uses entirely symbols. We will represent everything using just symbols. Symbols can be anything from constants, which are like the gas constant R or pi. Okay, these numbers never change and they're always the same value. Other types of symbols are variables, such as time and velocity. These are numbers that will change problem to problem and could be anything. Okay, so what we do in a literal equation is we will isolate the unknown. And the unknown is anything that we are trying to solve for in a problem. So if you are trying to solve for velocity in a problem, then our goal of a literal equation is to isolate the unknown, which in our case would be velocity. Okay? So how are we going to do this? Well, first we're going to use some algebra, and then secondly we're going to have to know PEMDAS, which is order of operations. And so these are two basic principles of math, and we will use both of these to figure out how to solve for the unknown. So here's our first example. We have our equation F equals ma, which is basically force equals mass times acceleration. Our job today and what we want to do is we're going to solve for acceleration. Acceleration is what we want to find out, and acceleration in this case is going to be our unknown. So what I'm trying to do is I'm trying to isolate acceleration. I want a by itself. So right now the thing that's keeping me from having a by itself is m for mass. So what I want to do is I want to get rid of mass, and I'm going to move it. Okay? The way I move it in algebra is I do the opposite of what's happening. And right now mass and acceleration are being multiplied. So the opposite of multiplication is division. So when I divide mass on one side, I have to divide it on the other side as well, because it's algebra. Whatever you do to one side has to be reciprocated and also divided on the other side. Okay? Mass divided by mass is 1, and so they kind of cancel each other out, even though they technically don't, but for our purposes they do. Okay? And so on this side, I'm left with only a, and then on the other side, I have F force divided by m. Okay? And then my last step is just to switch it. What if a is equal to f over m, I can just swap both sides, and a is equal to f over m. And that is my final answer. Okay? So, simple, easy. All it really requires is a knowledge of algebra and order of operations. So here is another example. Example 2. V equals distance over time. Velocity or speed equals the distance you traveled divided by the time it took you to actually travel that. Okay, this time t is going to be our unknown that we are going to solve for. So I have to ask myself, what is keeping t from being isolated and by itself? Well, that's going to be because, well, so d on top is what's keeping t from being isolated. Okay, but here's the trick. Anytime you have your unknown on the bottom, you have to get it on the top somewhere. So what I'm going to do is I'm going to multiply both sides by t. And you might question, like, well, what are you trying to do? I thought we were trying to get rid of the d. Well, we are, but first we have to move the t from the bottom and get it on the top somewhere. So I'm going to do that by multiplying both sides by t, which will cancel out to 1 on this side, and then on the other side I get t times v. So now d is left alone, but my t variable for time is now on the top, which is what I really need to do before I can do anything else. Okay? So now you can see that the problem is velocity, v. So now we can just do like what we did last time and just cancel v to 1 and move it to the other side. So now time is equal to distance divided by velocity. Okay? And so that would be solving this equation for t. Okay? And let's look at our... Oh, don't do that. There we go. Let's look at our third example. We're going to solve the famous E equals mc squared. Okay? And for our purposes, we want to find out C. What is our unknown C equal to? We're going to solve and isolate C as our unknown. Okay? So I'm again going to ask the same questions. Order of operations, we're going to start with multiplication first. And we're going to find that m is multiplied by c, so that's going to be the first one that we can move. So I'm going to divide both sides by m. M will cancel out to 1 on this side, and so I get c squared equals to e divided by m. Okay, so now I have this problem with the squared. What do I do with that? Well, I'm going to, all of a sudden, in my thought bubble, I remember from Algebra 1 that x squared, if I take the square root of x squared, that just gives me x. So that's what I'm going to need to know, and that's what I'm going to apply to this. If I take the square root of both sides, because whatever you do to one side, you have to do to the other, the square root of c squared just gives me c. And then on the other side, I'm left with the square root of e divided by m. Okay? And then again, I want my isolated variable to be on the left side. So I'm going to flip both sides and rewrite c equals the square root of e divided by m. And that is what my isolated variable is. So c, the speed of light, is also equal to the square root of energy divided by mass. Okay? So some of you may be able to see why this is going to be really useful, and some of you will not be able to see that quite yet, but once we start getting into physics problems, it will be very obvious. So that's the end. Rewatch this video as many times as you need to. Make sure you have notes, and then on Friday we will solve more problems and talk a lot more about literal equations.